Hello, ladies and gentlemen. This is Mr. Hunter, and these are your motion graph notes examples. In the previous lesson, I gave you guys the general outline of how motion graphs work, and we use them because we can determine the motion of an object, including its speed, its velocity, and the distance it travels from certain types of graphs. So in this first graph, in this first example today, please remember to actually draw these examples down. I can print these out, so if you want them printed out, please ask me for them. But for right now, if you guys can just quickly record the numbers and the graph itself as well, but you don't need all the mini squares, just the numbers and the x and y axis. So this is a displacement time graph, and what this tells us is it tells us kind of how the object moves. So on the x-axis, I have my time, and on my y-axis, I have displacement. And my first question, which you should also be please writing into your notes, is the slope of this graph tells us the object's what? Well, slope is rise over run, and it's my change in y over my change in x. So since it's my change in y over my change in x, my y is meters, my x is seconds, and you guys know what the unit of that is. It's velocity. So because it's meters per second, I could determine from the slope, because the y-axis is meters and the x-axis in seconds, I know that the slope of that graph tells me velocity. And at certain points in time, you could tell me what the velocity is. For example, from 1 to 2 seconds, you should know that the velocity is 0 because the slope of that line is flat. Just a reminder, never use displacement over time and like acceleration equals change in velocity over time. We actually never use the actual physics equations. So just remember that, because some of you forgot that from last time when you were doing your examples in class. Don't use physics equations. You only use slope or area. So only use slope or area. That is critical, because if you use the equations, you will get the wrong answer. There's a caveat, which you could probably figure out. I am not going to tell you that caveat. So what is the displacement that the object travels? So if you remember, displacement is the shortest distance from the start to the end. So I go 15 meters away from my origin in the first second, and then I stand still there for one whole second, and then I walk back to my origin. So in terms of displacement, my displacement would be 0 meters. Why? Because I ended where I started. Now, what is the distance the object travels? This is a little different, right? So in my first leg, I walked 15 meters, and then I stood still, so I moved 0 meters, and then over span of 2 more seconds, I moved 15 meters back to the origin. So my total distance that I moved was 30 meters, because I add up all of the legs of the journey to get my total distance. Then lastly, I asked, what is the object speed at 3 seconds? So for example, just like I said, I don't use physics equations, only use slope or area, except for this one example. And the reason why I laugh is because in this case, you actually have to use a physics equation. It says, what is the object speed at 3 seconds? Well, you could still not use the equations in here. And the reason why is you're supposed to find the slope of the line at 3 seconds. But in order to do that, you'd have to figure out the slope of the line. So let's quickly figure out the slope of the line. So technically, I want it at 3 seconds, but this slope is constant, and it's also negative, so we have to just pick 2 points. So let's pick 2 easy points. I'll pick 0, 4 as my second point, and I will pick 2, 15 as my first point. So remember, it's delta y over delta x. So I have the 2 points of 215, and then I have 0, 4 is my second point. So it's y2 minus y1, so it's 4 minus 15 over x2 minus x1, so it's 0 minus 2. Is that correct? Let's see. It's y2 minus y1, right? So y2 minus y1. I did something wrong here. I could tell I did something wrong. Because this is not 0, 4. It is 4, 0. And that is 215. Okay, now that my numbers are right, you're like, good job, Mr. Hunter. Hopefully you caught my error. But knowing my experience, most of you probably didn't. But I looked, and the math, the slope is negative, so I was looking for a negative number. That's how I knew I did something wrong, because that answer wouldn't have been negative. And so I was like, something's not right here. So then I have 0 minus 15 over 4 minus 2 equals negative 15 over 2 equals negative 7.5 meters per second. Notice I get a negative because I know the slope is a negative value, so that makes sense. And that negative just means I'm moving back towards the origin. So in this case, at 3 seconds, I am moving at 7.5 meters per second. Or excuse me, -1/2 meters per second. Okay, so that was the first graph, and it took me 6 minutes to do that, which is not cool because there's 4 graphs, but I'll only give you 2 today and call it. So the second graph is a velocity time graph. So this tells me if I look directly at any point in the graph, that will tell me its velocity at that point in time. So make sure you copy this down. You might have to pause it because I'm moving on. The slope of this graph tells us the object's what? Well, let's do just like we did before. Delta y over delta x. The units on the y are meters per second, and that's divided by the unit on the x is seconds. So now I do my keep change flip. I get meters per second times 1 over seconds equals, and you multiply straight across, meters per second squared. So that is the unit that hopefully you should recognize for by now is acceleration. So the slope on a velocity time graph tells you its acceleration. So then I said, hey, at 2 seconds, how fast is the object traveling? Oh, that should be an easy question. The reason why is because this is a velocity time graph, and the question literally asks us and says, hey, what is the object's speed at 2 seconds? Well, since this is a velocity time graph, I literally just come and I look at 2 seconds, go up. Oh, at 2 seconds, I'm at 10 meters per second, so that's my instantaneous velocity at that point in time. So it's 10 meters per second. If you're not sure how I got that, pause it, go look back at the graph. But I look at the graph and I say, hey, it's moving at 10 meters per second when I hit 2 seconds. Then I said, what is the acceleration of the object from 1 to 3 seconds? Show math. So from 1 to 3 seconds, right, we have to find, once again, we have to find the slope of this curve. So let's just pick 2 easy points. So I'll pick 1, 5, and I'll write them correctly this time. And I'll pick 3, 15. So now I need to find the slope. So once again, my numbers were 1, 5, 3, 15, and it's delta y over delta x. So that is 15 minus 5 over 3 minus 1 equals 10 over 2, and it's meters per second equals 5 meters per second squared. The unit makes sense. It's acceleration, so it's meters per second squared, and then it's just 10 divided by 2. So once again, I found the slope to find the acceleration. You got to remember those things. Velocity, time. If you want acceleration, you got to do the slope. If I want distance, I have to do the area under the curve, just as it said in your previous notes. So number 4, I said, how far does the object travel from 3 seconds to 4 seconds? So in this case, I want the area under the curve to give me distance. Remember, the slope gives you acceleration. Please write this down because some of you didn't write it down in the previous notes, and then when I asked you in the problems, you had no idea what I was talking about, which is not cool. And then the area tells you distance. So distance is just simply, it's going to be length times width here. The width is 1 second, and then my length would be 15 meters per second. So I'm just doing the math right here since we're here. 15 meters per second times 1 second. The seconds cancel out, and the object traveled 15 meters from 3 to 4 seconds. So the object traveled 15 meters, and I got that using area equals length times width, where one was 1 second and the other was 15 meters per second. So once again, the seconds cancel, and I'm left with 15 meters. And I am out of time, so I'll show you those two graphs for now, and then I'll give you another homework that shows you two different types of graphs. The goal is to get comfortable analyzing the object's speed, velocity, acceleration, and distance from different types of graphs. I will be checking this Wednesday morning.